there we go. Okay, I think we're live now. So let me know if you guys can hear me. And if we're live, if you're in the chat. I was helping out a couple Math 1 students, and then I kind of forgot how to do this, so it took me a little bit longer than I wanted to or I anticipated. But I think we're good to go now. So I will wait to get confirmation. I think it says that there is at least one person viewing. So if you're viewing, just kind of put in the chat, yes, it's working, and you can hear me all right. So those are all of our answers. Here we go. All right, so again, one more time, I just want to make sure that this is working right. So it looks like 2 of you guys are viewing. Just put in the chat for me if you guys can hear me all right, so that I don't do this all and kind of waste my time and have to record it again later. So I'm going to go ahead and get started with number 1. I'm hoping that we're good. Yeah, awesome. Thank you, Anthony. So this is kind of a common question, is we're going to get this graph of f prime of x. Right? We're going to get a graph of f prime of x, and then we're going to have an integral. Okay. So I went over this in class, but just kind of remember that if you're given a graph of f prime of x, then, you know, basically for f, right, well, the y value, right, like f prime in this case would be the y value, right, because that's the graph. So if we want the integral from 0 to 4 of f prime of x dx, since I'm given the graph of f prime, okay, this is actually just the area under the curve. Okay, so this is just the area under the curve. So this one's a little bit weird. So what we're going to do is we're going to do the area from 0 to 4, right? Because this is f prime, and that's what's in here. So we want to kind of remember that, you know, if we have the integral on a graph, that's the area under the curve. So that's a triangle, and that's a semicircle. So the area of the triangle is 1/2 times the base is 2 times the height is 4. This is a little bit more review from last semester. And I'm going to put minus because this is below the axis. It's a quarter circle, so that's 1/4 pi times the radius squared. The radius of this guy is 2. So that's 4 minus 4 and 1/4 will cancel, pi. So again, this is more review from last semester, just to kind of differentiate between that, and then later on we'll have ones that are more with the FTC. All right, what is the average value? Again, we're gonna have to remember average value. So this is kind of average value with u sub, so kind of like a new take on average value. So you need to remember your average value formula. You do have to know that for the test, is 1 over b minus a times the integral from a to b of f of x dx. So in this case, we would do 1 over 2 minus 0. Right, that's our a and our b. Feel free, by the way, if you're watching, feel free to put any questions that you have in the chat. I might see them late, but I'll go back to them, okay? So if you have any questions on anything I did, like why did I do something, just go ahead and put that in the chat, and I can go over it again. Okay. So this one, the 1/2 is extra, but really it's just a u sub question. So it's a u sub question just with the added 1/2 in the front. So my u is going to be anything inside of my radical, so the x cubed plus 1. And my du will be 3x squared dx. So I'm going to highlight this, just make it easier on us. So we have our u is the x cubed plus 1. That's going to turn into u. For du, I want 3x squared dx. So that's what I want. I want to have a full 3x squared dx. But all I have right now is x squared dx. So what am I missing? I'm kind of missing the 3, right? That's what I'm missing. So I need to multiply times 3 inside, and that means I would multiply times 1/3 outside. So that's going to go ahead and give me, 1/3 times this is 1/2 would be 1/6 outside. And then the 3x squared dx, that part's going to become du. And then we'll have square root of u. Now, for my endpoints, you can do one of two things. Remember that you can either keep them the same and just change u back later, or you can change them now. I do really like to change them. So I'm going to go ahead and change them. So to change them, you plug them both in for x. So 0 cubed plus 1 gives me 1. 2 cubed is 8. 8 plus 1 gives me 9. Now, in order to take this integral, I'm going to change it into exponent form. So u to the half power, right? Instead of square root, u to the half power. And then we just take the integral, right? You add 1 and divide by it. So u to the 1/2, when we add 1, 2/2 plus 1/2 is 3/2. So this is u to the 3/2 divided by 3/2. Now remember what I've told you guys, instead of doing divided by 3/2, you can just flip it and make it 2/3. And that's from 1 to 9. I'm going to go ahead and kind of simplify this a little bit. That cancels like that. So this would become, I'm going to write it up here, just make it a little bit nicer. This would be u to the 3/2 over 9. U to the 3/2 over 9 from 1 to 9. And so this will give me 9 to the 3/2 over 9 minus 1 to the 3/2 over 9. Now, how do you do 9 to the 3/2? This is not a calculator test. How do I do 9 to the 3/2? Well, that's the square root of 9 cubed. You can do either the square root or the cubing first. I like to square root first. It makes it easier. The square root of 9 is 3. So this would be 3 cubed. 3 times 3 is 9, times another 3 is 27. So this is going to give me 27 over 9. Right, so I kind of square rooted first. The square root of 9 was 3, and then 3 cubed is 27. Minus 1/9. Right, I know 27 over 9 is 3, but don't do that because I have to subtract, so I'll get 26 over 9. So we get 26 over 9, and so that is choice A. So this was a lot of work. This was probably hard. This is definitely actually harder than I'm going to make on the real exam. So if you can do this, then you'll be in good shape. On the real exam, I might throw average value in there, but I'm not going to make the, I won't make it as hard to plug in, like this 9 to the 3/2. I won't make you do something like that. Next, pictured to the right is the graph of the derivative of a function, g prime of x. And it is known that g of 0 equals -3. What is g of -4? Again, this is kind of more back to last semester, but I just wanted to throw it in there. I'll be super, super honest that number 3 is probably not going to be on your test, but I may do it as a bonus, okay? So it might be a bonus. So we have this kind of fundamental theorem of calculus from last semester where basically we know this is the graph of g prime. How would I get g prime back to g? I would take the integral, right? And so the endpoints that I would want would be 0 and -4. So I would kind of say from -4 to 0 of g prime of x dx, this would equal g of 0 minus g of -4. Again, this is last semester, so it might be a bonus. And this was kind of the FTC part 1. So to get this part, this is the area under the curve. So from -4 to 0, okay, that's a little triangle, that's a little triangle. These I could actually just kind of cancel them out. And then I have a rectangle and a quarter circle. Okay, I'm not going to cancel them out. I'm going to just do them. But if you wanted to save yourself time, you could cancel them out. So below the axis is negative 1/2 times the width is 1 and the height is 1. Then above the axis, 1/2 times 1 times 1. Then this rectangle is base times height. The base is 2, the height is 1. And then the quarter circle, 1/4 pi times 2 squared. And that's going to be equal to g of 0 they gave me was -3 minus g of -4. Oops. So that's -1/2 plus 1/2 plus 2 plus pi equals -3 minus g of -4. Just cancel. Add 3 to both sides. We get 5 plus pi equals negative g of -4. So I would divide everything by -1, and that's choice B. Okay, that's choice B. Number 4, again, is also kind of review. Number 4, same thing, probably not going to be on your test, but it might be as a bonus. So the integral from 1 to 3. Now, instead of f of x, they're telling me that f of x was g prime of x. G prime of x. So I could do FTC and say this would be g of 3 minus g of 1. So I could just do g of 3 is x squared minus 3x plus 4. And I get 4. Then I could do g of 1 would be 1 squared minus 3 times 1 plus 4. That's 2. And so this would be g of 3 was 4 minus 2, and I would get the answer of 2. I could have as well, there's a longer way of doing this. I could have literally solved for g prime of x and said that's 2x minus 3. And then we could have done the integral from 1 to 3 of 2x minus 3 dx, and we could have literally just taken that integral, got an x squared minus 3x from 1 to 3, and then plugged it in. Right? 3 squared is 9, 9 minus 3 is 0, minus 1 squared is 1, 1 minus 3 is -2. 0 minus -2 would give +2, which was our answer. So that could have worked as well. Number 5, very, very similar to number 3 that we just did. Again, not on our test. Okay, but maybe as a bonus. I did throw a few of these in the first 5 questions. I threw a lot of review at you, okay? And then it's going to get into the stuff that we've been doing, like the slope fields and the differential equations. But I did want to throw some review at us because it's important. So same kind of deal is we're given the graph of f prime, right? So we have the integral from, I'm going to use 0 and 2. Those are my x points of f prime of x dx will be f of 2 minus f of 0. Again, this is, same kind of thing, that FTC number 1. So again, FTC number 1 was not from this chapter, but I might have it as a bonus on our exam. So from 0 to 2, starting at 0, going out to 2, there's a rectangle and a semicircle. They're both above the axis. The rectangle has a base of 2 and a height of 1. And I said semicircle, it's a quarter circle. The quarter circle has a radius of 2. So it'd be 9 minus, my fault, f of 2 minus 9. Right, f of 0 was the 9. So this gives me 2 plus pi, right, those cancel, equals f of 2 minus 9. Add 9 to both sides. We get 11 plus pi would be f of 2, which is choice E. So that should be it for the review. So now we'll kind of move on to some of the newer stuff we've been doing this chapter. So this says the slope field pictured below represents all general solutions to which of the following differential equations? So what I like to do on something like this is to just kind of pick a point to plug in. So, maybe I plug in at 1, 1, I'm getting something negative, right? So, 1, 1, I'm getting something negative. So if I plug in 1, 1 here, well, I only have an x, so if I plug in 1, 1, I get positive 2. Well, this was a negative slope, right? The reason I know it's negative is it's pointing down. But when I plugged in 1, 1, I got 2, so this cannot be right. Here, if I plug in 1, 1, I get negative 2. This could work. It doesn't have to work, it just could work. Here, if I plug in 1, 1, I get negative 1. Again, it could work. It doesn't have to work, but it could work. Here, dy dx equals y. If I plug in 1, 1, I get positive 1. This cannot work. And here I would get 1 plus 1, which is positive 2. Again, cannot work. So now I'm in between B and C. So now let's plug in something in another quadrant. I always pick different quadrants to plug in. When I pick a new quadrant, usually it's going to help me out. So I plugged in quadrant 1. Now maybe let's plug in something down here, right? Like 1, negative 1. Oops. Right, the x is positive 1, the y is negative 1. And my slope is pointing up, so that's giving me a positive slope, right? A positive slope. So let's try plugging in. X is 1, y is negative 1. So here, if I plugged in, right, negative 2 times 1, I get negative 2 again. But I wanted a positive slope, so that does not work. Let's just verify that C does work. Negative, we're plugging in negative 1. Gives me positive 1, which is a positive slope. Yes, that worked. So my answer is C. So it's kind of just process of elimination there. You just kind of keep going and process of elimination. Next up, this is a super common type of question. I really, really like this question. So this is definitely a very, very common question that we could have. And so we're given h of x equals the integral from negative 2 to f of t, and we're given the graph of f. So what we want to immediately do is just kind of write down h prime of x would be the derivative, so it'd be f of x. And they're asking me to compare h prime, and h double prime. So I want to kind of think, well, h of x was the integral from negative 2 to x of f of t dt. And so what would be h double prime of x? Well, h double prime of x would be the derivative of this, which would be f prime of x. So kind of looking at it graphically, h of x is going to be the area under the curve, from negative 2 to x. F of x is going to be our y value. And f prime of x is going to be our slope, right? Because it's f prime. So h double prime will be our slope. So now kind of looking at these, they want us to compare these. And generally what happens, almost always one of these will be positive, one of these will be negative, and one of these will be 0. So you want to kind of arrange it for your negative will be smaller than 0, will be smaller than your positive. So if I look, they're giving me h of 4, h prime of 2, and h double prime of 3. So h of 4, I don't care what it is, I just care is it positive, negative, or 0. If I plug that into the equation from negative 2 to 4 of f prime of t dt, that's the area under the curve starting at negative 2 going to 4. So that negative area, then this positive area, and then this positive area. Well, we can kind of see those should cancel out, and that's positive. So h of 4 is positive, right? So I could kind of maybe write on here h of 4, right, is positive. Okay, now let's check h prime of 2, right? H prime of 2. So we'll use another color. H prime of 2, we said up here would be equal to f of 2, right? Would be f of 2. So that's the y value. Well, at 2, this is also positive. So my theory kind of is not working out so nicely, but we'll go with it. Okay. And then also h double prime of 3, that's going to be f prime of 3. Well, we know this is negative. Okay. So h prime of 3, that is negative, right? Because that's the slope right here, which has a negative slope. So immediately, I know that h double prime of 3 has to come first. So I could cross out a, b, and c because it's negative. So now I just need to think which one is more positive. Well, which one is more positive? Well, what would h prime of 2 be? H prime of 2 is the y value. So h prime of 2 will be 2. And then h of 4 is my integral. So for h of 4, I'll use another color. Let's use green. Was my integral from negative 2 to 4. So we said that these canceled out. Those two areas canceled out. So really, it just ends up being the area of that quarter circle. So h of 4 will be 1/4 pi times the radius is 2 squared, which will be pi. Well, pi is bigger than 2, right? Pi is bigger than 2. So I know h of 4 is my biggest term, so it's choice E. So that one is a little bit tricky. Generally, you're trying to see that one's positive, one's negative, one's 0. But in this case, if you get two that are positive, then you just have to see which one's bigger, right? So h of 4 was the biggest, and h prime of 2 was the kind of middle, and then h double prime of 3 had to be the smallest because it was a negative slope. Right? Number 8 gives us a graph of a piecewise. Again, we have this g of x equals the integral from negative 2 to x. And I say which are the greatest, and they're all g values. So they're all g values. So in this case, it's the integral from negative 2 to negative 3 would be a. Right? The integral from negative 2 to negative 2 would be b. The integral from negative 2 to 0 would be c. The integral from negative 2 to 1 would be d. And the integral from negative 2 to 2 would be e. So, we're plugging it in there. Right, because it's g. If it had said g prime, then we would be looking at the y values. If it had said g double prime, we would be looking at the slopes. So in this case, I know this is 0, right? Anytime that endpoints are the same, I get 0. So I'm going to kind of look at a. So on a, I'm going to start off at negative 2. I'm going to go backwards to negative 3. Well, remember when we go backwards, we get a negative answer. So a is going to give me a negative answer. I'm going to cross out a. I know it's not a. B is going to give me 0. I know it's not B. Okay. For C, let's use blue. So on C, I'm going to start off at negative 2. I'm going to go forwards until I get to 0. So this is C. So it's a positive answer. So it could be C. But then D ends up being even more positive. D ends up starting at negative 2 and going to 1. So it ends up being all that blue area plus that extra area. So D, I'm going to kind of say it's even bigger positive. And then on G, what happens on G is it goes until positive 2. So I get all of this area from the previous one, but then that's negative. So I'm kind of subtracting a little bit. So it's, my big positive, but then I subtracted a little bit. So which one of those is the biggest? Well, the biggest would have been D. Right, like the biggest area would have just been that biggest positive section where I didn't have to subtract anything. So just kind of looking at the graph and kind of process of elimination. 9, the graph of this function has a horizontal tangent at x equals 4. That means the slope there is 0. And at x equals 8, the slope there is 0. And they say if g of x is equal to x squared minus the integral from 0 to 2x, what is the value of g prime of 3? So if I want to get g prime of x, before I get that, of 3, I need to do g prime of x. So the derivative of x squared is 2x minus, so this is that fundamental theorem of calculus number 2 that we did at the beginning of this chapter. So the derivative of 2x is 2, and then f of 2x. So not f of t, but f of 2x. We plug it in. So now if I want to get g prime of 3, we plug in 3. This is 6 minus 2 f of, if I plug in 3, I get 6. So what is f of 6? Well, they gave me the graph of f. So the y value at 6, right? And in this case, it's kind of hard to read that, but there's 6. The y value is negative 2. So g prime of 3 would be 6 minus 6 would end up being 0. So in this case, see if I made a mistake here somewhere. Oh, yeah, I don't know what I'm doing. Okay, the y value is negative 2. So minus 2 times negative 2. I don't know what the heck I just did. I don't know how I got 6 there. I plugged in the x. So f of 6 is negative 2. It's been too long of a day. So 6 minus 2 times the y value is negative 2 would be 6 plus 4 would be 10. So the choice is B. Again, if you get stuck on any of these, or if you guys have a question on these, just put it in the chat and I'll answer it. Next, we see which of the following is the solution to the differential equation dy dx equals 2 sine of x. So dy dx equals 2 sine of x. This one's a little bit easier because there's no y. There's only an x. So I just need to multiply times dx to both sides. Those cancel, and we get dy equals 2 sine of x dx. Then we'll take the integral of both sides. The integral of the left side of dy just gives me y equals. Then on the right side, the integral of sine of x is negative cosine of x. So we need to make sure we have those memorized. The integral of sine is negative cosine. That's because if I took the derivative of cosine, it's negative sine. So I need to have that negative there. And then we need the plus c. So just from here, we could cross out a and b. And then we're going to plug in y of pi equals 1. So for my y value, we'll plug in 1. Negative 2 cosine of pi plus c. You need to make sure you have your unit circle and your trig table memorized. So cosine of pi is negative 1. So this is 1 equals negative 2 times negative 1 plus c. That's positive 2. Subtract the 2 over. We get negative 1 is c. So we take that and we plug it in there. So we get negative 2 cosine of x minus 1. So our choice is E. Right. Moving on, the graph of the function shown above has horizontal tangents at x equals 2 and x equals 5. Sometimes that helps us. Sometimes, like in that other question, it's just a distraction. Let g be the function g of x equals the integral from 0 to x of f of t. For what values does g have a point of inflection? So this is definitely a question I could ask you on the exam that does require you to go back to last semester. So where do we get a point of inflection? Points of inflection are when g double prime changes signs. So we need to be thinking about g double prime. Well, what is g of x? G of x is the integral from 0 to x of f of t dt. So as soon as you get that, it's really, really good practice to write out g prime of x would be f of x, right? When you take the derivative, that just plugs in. Kind of the integral goes away, right? If, it was anything other than x, we would have to do chain rule though. And then g double prime of x would be f prime of x. So graphically, since they gave us the graph of f, right? They gave us the graph of f. This is where students kind of get confused. is on the graph, this is the area. G matches up with the area. G prime matches up with the y value for the graph. And then G double prime matches up with the slope of the graph. So if I want to know where G double prime changes signs, I'm really looking at where does the slope change signs. So here it was increasing and it changed to decreasing. It was decreasing and it changed to increasing. So where did that happen? Happened at x equals 5 and x equals 2. Now, another question they could have asked us, instead they could have said maybe, where does the graph of G have maybe a maximum? Well, if they asked me where I had a max, that would be when G prime goes from positive to negative. Okay, well, what was G prime matching up with? It was the y value. So where did the y value go from positive to negative? That would be at 4. So this one would have been at 4 only, right? That would have been my maximum. So that's another possible question that they could ask us that's a little bit different. So make sure that we kind of understand the difference and how to do each of those. 12 is a super, super common multiple choice question. It's definitely going to be something that I ask you on your exam. And what they do is they give us a substitution and then they ask us to kind of perform it. Now, the best advice I can give you if you get stuck is to remember to plug in your points. So I like to just kind of rewrite this on the side, 1 to 4, e to the square root of x over square root of x dx, and then just put u is equal to square root of x, du is equal to 1 over 2 square root of x. You can usually figure out the answer on these without even if you messed up. Because what has to happen is these have to plug in, right? So our new integral is going to be the square root of 1 is 1, the square root of 4 is 2. So immediately I can get rid of choice A, I can get rid of choice B, and I can get rid of choice E, because all of those had bad endpoints. And so now I'm in between C and D. And it's kind of a toss-up, but if you're smart, look at the distractors. This had a 2 in it, this had a 2 in it, so it's probably C, right? It's probably C. But let's just kind of verify it and make sure. So what am I missing from this, right? Well, this is my u, right? Square root of x is my u. And then, that's a bad color to go with. This square root of x in the denominator, 1 over 2 square root of x in the denominator dx, that's my du. Well, I have square root of x in the denominator. I'm missing the 2. But remember, where is that 2? That 2 is in the denominator. So I need to do times essentially 1/2 because I want to put a 2 in the denominator. What's the opposite of 1/2? 2 over 1. So 2 over 1, e to the u, and then this whole part becomes the du. So that's why it is choice C. But like I said, a lot of times on these, you can kind of just say, okay, those are my proper endpoints, and yeah, it's got to be the 2. Okay, I would still double check it, but that's kind of a hint. Okay. All right, here's another u sub, but this time you actually just have to do it. So the u would be the negative 4x. The du would be negative 4 dx. So I'm going to multiply times negative 4 inside times negative 1/4 outside. So this gives me negative 1/4 integral from 0 to 1 of e to the u du. That's negative 1/4. Now, I could go back and do e to the negative 4x from 0 to 1. That would work perfectly. So making sure that I know that because of that, I need to plug it in. Or we could have also changed our endpoints. We could have done negative 1/4 integral, and we could have changed our endpoints by plugging them in. 0 times negative 4 is 0. 1 times negative 4 is negative 4. And then when I take this integral, we would just keep it with a u. we would just keep it with a u because we have new endpoints. So both of these are correct. I don't care which way you do it. Okay? You can do it where you keep your endpoints and you plug back in u, or you can do it where you keep u and you change your endpoints. But the reason why you absolutely need to know how to do this kind of way where you change your endpoints is for this question back here. Right, on this question where they ask you about the substitution, they're always going to have changed the endpoints. So you need to kind of remember, especially for this question, that you always need to change the endpoints. Now, when you do it yourself, when they're not asking you, for something with the u in it, you can do either method. You can say, hey, I want to plug back in u, or I want to keep u the same and change the endpoints. Okay, I'm going to do this one. So if I plug in -4th, that's -1/4 e to the -4 minus -1/4 e to the 0th. But had I plugged in here, you're going to get the same answer. Okay. Now, whenever I have a negative exponent, it goes to the bottom, to the denominator. That's -1/e to the 4, -1/4 e to the 4th, minus e to the 0th is just 1, so -1/4. And actually, they didn't bring it to the denominator, did they? So if I look at their answers, it's always e to the 4th. So -1/4 e to the -4. Okay. So which answer looks like this? Okay, none of them quite look like that. So we kind of have to pick out, what we want. And so this is where it does get a little bit confusing. So, oh wait, I did make a mistake. So one of them does look like this. I made a mistake. Negative, negative, turn that to positive. Right? So none of them look like this because they put the number in the front. So what they did is they just moved the 1/4 to the front. So they said 1/4 minus 1/4 e to the -4. And then they just moved their e up here. So it's choice D. Okay. So make sure I've done that a couple times today. Make sure, negative times a negative is a positive. Or, when you have, subtracting by a negative, you get a positive. Okay. If f is the function given by f of x equals the integral from 4 to 2x times the square root of t squared minus t, then what would be f prime of 2? Before you can do f prime of 2, you always need to find f prime of x. So I'm going to do d dx, right? And this is chain rule with that ftc. So it's going to be 2 times the square root. Now you need to square the whole thing. So 2x all squared gives me 4x squared. Be very careful about that. You need to square the 2 and the x. And minus, you're also going to plug it in there, 2x. Now what would be f prime of 2? Well, now just plug in 2. So 2 square root of 2 squared is 4. 4 times 4 is 16. Minus 2 times 2 is 4. So you get 2 square root of 12. So that's choice E. Next one, we have another one of these slope field ones. And they say shown above is the slope field for which of the following differential equations. So again, I like to kind of pick something to plug in. So maybe at 1, 1, 1, 1 looks like it's something over here. So if I plugged in 1, 1, I'm getting a positive slope. So I'm going to plug in, x equals 1, y equals 1, and make sure that I get a positive answer. So on choice A, 1 over 1 is positive. It's still in play. Choice B, 1 cubed over 1 is positive. It's still in play. Okay. Choice C, 1 cubed over 1 squared is positive. It's still in play. Choice D, 1 squared over 1 squared is positive. It's still in play. And choice E, 1 squared over 1 is positive. It's still in play. So that didn't help me at all, which is okay. So now try another quadrant. Okay, so next after that, we'll try another quadrant. So now, maybe I'll try -1, 1. So -1, 1, I'll use a new color. Okay, so x is -1, y is +1. And this is a negative slope. It gave me a negative slope. So when I plug in these, I should get a negative slope. So x is negative 1 over positive 1. That is negative. So this one's still in play. Negative 1 cubed is negative over positive 1 is still negative. This guy's still in play. Negative 1 cubed is negative over 1 squared is still negative. This guy's still in play. Okay. Negative 1 squared is positive. So we can cancel out D. And negative 1 squared is positive. So we can cancel out E. So now I'm in between A, B, and C. Okay, now go to another quadrant. Okay, maybe we'll go to quadrant 3. Okay, so at negative 1, right? That's a negative slope. So we're going to plug in x is negative 1, y is negative 1, and we should have gotten another negative slope, right? It's pointing down. It's pointing down. So in this case, negative 1 over negative 1, I got a positive answer. Negative 1 over negative 1 is a positive answer, but I wanted a negative slope. So we're going to cross that out. Right, I got positive. It should have been negative. Here, negative 1 cubed is negative 1 over negative 1. Again, is a positive answer, but that's a negative slope. I can cross that out. Now let's just double check our answers right. Negative 1 cubed is negative over negative 1 squared is positive. Right, a negative over a positive gives me a negative, and I wanted a negative. So choice C is the right answer. So they take a while, but if you just go slowly and just kind of do that pattern, like plug in 1 and 1, plug in 1 and negative 1, plug in negative 1 and negative 1, and just compare it to what your expected answer on the graph is, you should always be able to write these. Sam asked a really good question in the chat. She said, are there any specific points that you recommend using? I always recommend using 1 and, 1 and 1, 1 and negative 1, negative 1 and negative 1, because 1 is the easiest to plug in. If you're trying to plug in 2 or 3, then you're having to do like cube, it just gets nasty. So I always do that. In this case, I didn't do the zeros because they all had an X on top and a Y on bottom, so I knew that wasn't going to help me. But you can plug in zeros as well. I usually find zeros are kind of a little bit of a waste of time because you're going to have to do something like this anyways. So kind of my strategy would be to start off, basically start with x equals 1 and y equals 1, which is basically like quadrant 1, right? And I got positive. Then move on to x equals 1, negative 1, and y equals 1, which was like quadrant 2, right? Then go to x equals negative 1 and y equals negative 1, which is quadrant 3. And that's all I had to do. But if you still had 2 remaining, then go to x equals 1 and y equals negative 1, which is quadrant 4, right? In this case, my quadrant 4 should have been positive. And you should, that really should be enough. I've never ever seen a question where if you did 1 point from each quadrant, you couldn't determine an answer. If you still couldn't, I guess, then, try to look at the zeros or see which one's more positive. But I promise on our test, that will not happen, right? If you did 1 from each quadrant, you'll be good. But I always pick 1s because 1s are the easiest to plug in. You can pick anything you want, really. Next, here's another one of these. And again, my expected answer, I'm not going to guarantee this. The other one we saw that. But my expected answer is one thing should be negative, one thing will be 0, and one thing will be positive. That's what I'm hoping for. Okay, it doesn't always happen, and we saw what to do if it didn't on the last question, but this is kind of what I'm hoping for. So we've given this, I've shown this a bunch of times already, is as soon as we see that, kind of h of x is the integral from 0 to x of f of t dt, we want to immediately write h prime of x equals f of x, and h double prime of x equals f prime of x. This is super important. A lot of times on the AP exam, on the free response, if you get a question like this on the free response, literally just writing that will be a point. Like it'll be 1 point, and you could do nothing else on the whole question and you got a point. So it's really important to write that. Now, what is this? This is the area under the curve, from 0 to x. This would be the y value, and this would be the slope. Right? So now let's actually go ahead and do that. So we're comparing h of 6, h prime of 6, and h double prime of 6. Okay? So h of 6, that's going to be my area from 0 to 6. Well, that's a negative area. So h of 6 we know is negative. Now let's do h prime of 6. So what was h prime of 6? H prime of 6 was f of 6, right? F of 6. That's the y value. Well, that is 0. So far I'm hopeful that the next one will be positive. So the next one, h double prime of 6, that was our slope, f prime of 6, our slope. Right? And the slope at 6, it's increasing. If I drew a tangent line there, it's increasing the slope, right? So that's a positive answer. So then I know that basically the negative has to come first, will be less than the 0, which will be less than the positive answer. Right? Negative first, 0 second, positive third. So on h prime, h double prime. So the one that's h prime, and h double prime is choice A. That was just a coincidence that it went h prime, h double prime. Sometimes it'll go, h double prime, h prime, or h double prime, h prime. It could go in any order. What we need to just make sure that we're doing is we're, connecting, okay, h is the area. If it's below the axis, it's negative. If it's above the axis, it's positive. Okay, then h prime here is the y value. So obviously above, 0, or below. Then f prime would be the slope, right? Increasing slope, we could have a decreasing slope, or we could have a 0 slope at a horizontal tangent. 17 is another u sub. So u is equal to our denominator generally, so that's what I'm going to try. And du would be, in this case, 2x dx. Remember for u's, if you have a denominator, you want to try that. If you have e to something, you want to try, the exponent. If you have a square root, you want to try what's in the square root. If you have sine of something in parentheses, you want to try what's inside the sign. And then the last one would be, maybe if I have sine of x, cosine of x, then you want to actually literally try like sine of x. So that's the only weird one. Otherwise, it's usually pretty obvious what your u is. So in this case, we're going to use u as x squared minus 4. And then du would be the 2x dx. Well, I have the x dx part. I'm missing the 2. So I need to multiply times 2 inside and then times 1/2 outside. So it's going to give me 1/2 integral of 1 over u. And I like to put the du at the end. It could be on top as well. That's 1/2 ln of u plus c. Then we plug our u back in, 1/2 ln of x squared minus 4 plus c. So we get choice C. Some of you guys might have been able to do this in your head. If you kind of notice, okay, my u is the x squared minus 4. And my du is 2x. I know it's going to have to be a half, and then it's going to be an ln. So c is the only one with a half and an ln. You'd kind of, maybe do it quicker. I like to take my time and really verify that I have the right answer, though, by actually fully doing the equation. Okay. 18 is one of those exponential growth problems, exponential growth or decay problems that we saw. So bacteria in a certain culture increase at a rate proportional to the number present. As soon as we see that, we know that we have dy dt equals k times y, which gives us y equals y naught e to the kt. We know that this is a logistic growth question. If the number of bacteria doubles in 3 hours, how many hours will the number of bacteria triple? This is actually a pretty tricky question. So what we have to do first is the number of bacteria doubling, okay? When the number of bacteria doubles, we know that y is now equal to 2y naught. Okay? So if you ever see half-life, right? Half-life was when y was equal to 1/2 y naught. Well, doubling would be when y is 2 y naught. So that's what I'm going to kind of plug in here. So I'm going to go ahead and plug in 2 y naught, right? Because it was doubling. It's equal to y naught e to the k. And now for t, they told me that happened at 3 hours. So times 3. So the y naughts can cancel, and I get 2 equals e to the 3k. Okay, how am I going to isolate for k? I want to solve for k. We're going to take the ln of both sides. And so that will give me the ln of 2 is equal to 3k. I'll divide 3 by both sides, and I get ln of 2 over 3 is equal to k. That is not the answer I'm looking for. That's k. Okay, but that's not the answer. And they were nice. They didn't put that as an answer. Right, so let's reread. What did they ask me for? They asked me for in how many hours, so that's a time, will the number of bacteria triple? Okay. Well, now I know that my k is ln of 2 over 3. So I can write y is equal to y naught. I still don't know what the original is, but e to the ln of 2 over 3 times the time. So now I've kind of narrowed my equation down. I still don't know what y naught is. So if they gave me a y naught, then I would have like a full equation. But it's okay because they said in how many hours will the number of bacteria triple? So that's kind of plugging in for y, 3y naught. And again, they'll cancel out. So I'll plug in 3y naught equals y naught e to the ln of 2 over 3. This time I'm solving for the time. So the y naughts will cancel out. And I get 3 is equal to e to the ln of 2 over 3t. Then to get rid of the e, I'm going to take the ln of both sides. Those cancel. And I end up with ln of 3 equals ln of 2 over 3 times t. Now I'm trying to isolate for t, right? I'm trying to isolate for t. So you can do this one step at a time, or you can do it at the same time. Basically, I want to get rid of this, so I'm going to multiply by 3 over ln of 2. So times 3 over ln of 2. You got to multiply both sides by 3 and then divide it by ln of 2 as well. So it gives me 3 ln of 3 over ln of 2 is equal to t. And so that's in this guy right here. Oh, wait. I can't read right now. 3 ln of 3 over ln of 2. So that one's a little bit tricky. But, especially kind of doing this by hand, right? It's a non-calculator question, but it is doable. Sam asked if we're able to do it in our heads for the sake of time. Can we? Absolutely. Okay, absolutely. So were you talking about question 17, Sam? So I'm guessing she was talking about question 17. I really don't think you could do question 18 in your head. But for 17, yeah. When I'm grading your work and when I'm looking at the work, I'd probably look for you to maybe have written that down. But from there, yeah, absolutely, you could jump there in your head. So that's something I'm totally confident with you doing, right? Is, kind of just saying, okay, I know that, I have a 2x here. I'm going to have to multiply by the half. And then, yeah, I know it's going to be an ln, so it has to be choice C. So, that's definitely something that you can do to save time, especially if you're rushed for time. If, like, I'm saying, hey, we're halfway through and you still haven't finished the multiple choice, that's definitely something I'm comfortable with you doing. Or if you're just confident about it, absolutely do it. Save that time, right? Like shave off a minute and have a minute to go do something else. And then at the end, you could even, if you did that in your head, what I like to do is maybe even star it, right? And then at the end, if you have more time, then do it and check your answer by actually finishing it. So that's something that I would recommend for sure. Okay. Same thing for 19, right? 19 you could probably do in your head a little bit as well because it's another one of these U sub ones. So they gave us u was equal to x over 2, right? And if you ever have that, I like to kind of rewrite this as 1/2 x. I think it's easier to write as 1/2 x, right? So then our du is just the 1/2 dx, right? A lot of people, when they see x over 2, they try to do quotient rule. It's not quotient rule if there's not a variable in the denominator, right? If there's not a variable in the denominator, it's not quotient rule. So, or really in the numerator and the denominator. So here, this is really tricky. Okay, this is really tricky because that was that really weird u substitution. We had that one day where we had that really weird u substitution, where we had to kind of isolate for x and plug it back in. But this will get way easier if we kind of do process of elimination. So we're going to take our 4, we're going to plug that in, we're going to take our 2, we're going to plug that in. So we know our endpoints have to be the integral from 2 over 2 is 1 to 2. So immediately I can get rid of choice E and choice B. Now, if I look at those two, okay, so if I look at those two, 1 minus u squared over u and 1 minus u squared over 2u. Well, choice A and C both kind of match up with that. So it's probably not D. So I'm going to kind of cross out D just on a limb. And what do I have here? I have 1 minus u. Okay. Sorry, I have 1/2, right? What would I need to do inside? I would need to multiply by 1/2. And outside, I would need to multiply by 2 over 1. Right? Outside, I would need to multiply by 2 over 1. So I'm looking to have like a 2 outside. Neither case, I had a 2 outside. So something probably canceled, and that's because I had to kind of isolate for this. So I don't really know what the answer is, but I would lean towards A, because A is closer than, B is having a 1/2 outside. But at least I got a 50-50 shot between A and C. Like if you don't know anything else here, you got a 50-50 shot between A and C. That's way better than a 1 in 5 shot. So that's a really good, process of elimination step to help you out. Now, the way to do this one actually is let's just plug in for u. So this is 1 minus u squared over x, right? Now, what did I want? I wanted to have a 1/2 dx. So let's get that part out of the way. So let's do times 1/2, and then on the outside times 2 over 1. So now this is going to give me 2 integral from 1 to 2 of 1 minus u squared over x, right? I never got rid of this x, right? Because what happened was the 1/2 dx, that's what became du, right? And the x over 2, oops, that shouldn't have had a dx in there. The x over 2, that's what's became u, right? That's what became u. So I still have this extra, so this is going to become du. I still have this extra x in here. Because we never got rid of it. So what we have to do here, which is kind of tough, is we have to take this guy and we have to just isolate for x. Right, and it's a very rare question. I've only seen it a few times on the AP exam. And if you get it honestly, you're probably better off just taking that 50-50 shot between A and C if you get really stuck. But definitely, at least plug in your endpoints so you can cross out B and E. And then at least compare these answers. These were the distractions, right? Say, hey, this one looks like, this one looks like this one, and this one looks like this one. So it's probably not D. And now you're at least at that 50-50 shot. Okay. So anyways, kind of finishing this for real, and what the real answer is let's isolate for x. So we had u is equal to 1/2 x. Let me multiply both sides times 2 times 2. And so that means 2u is equal to x. So instead of putting an x, I can put a 2u. So now what will happen is I can get 2 integral from 1 to 2 of 1 minus u squared over 2u du. Now the answer is not C. Even though there's a 2u there, it's not C. And that's because that 2 in the denominator cancels out with that 2 over there. So the answer is A. So Really hard question because it's that this is like the basically U sub kind of like exception, which is where basically like this happens whenever you have an extra x. Right? And when you have that, you have to basically like solve for the x equals kind of what we did over here. But at least, if that's something you're not really as confident with, at least I think everyone could get to that 50-50 shot. Okay, and then last one, and then I'll do one more question that's kind of like a bonus for you guys who are here watching the stream. So during a certain pandemic, the number of people that are infected at any time increases at a rate proportional to the number of people that are infected at that time. I thought this was kind of a funny question. This was from like 1993, I think. It was a really old AP question, but it kind of fits with where we're at today. So it's kind of fun, or not fun. But when we see the proportional to the number of people, immediately, as soon as I see that, before I even finish reading the question, I know, I have dy dt equals k times y, which also gives me y equals y naught e to the k times t. So this says if 1,000 people are infected when the epidemic is first discovered and 1,200 people are infected 7 days later, how many people are infected 12 days after the epidemic is discovered? So 1,000 people are infected when it first starts. That's going to be my y naught. That's going to be my y naught. So now I can say y equals 1,000 e to the k times t, but I still don't know what the k is. I don't know what the k is. They didn't give me k. But they gave me a way to solve for it because they gave me a point. They gave me 1,200 people are infected at 7 days. So that's kind of like a, t and a y, right? On these, like, we would have points like t comma y, right? Kind of like x comma y. So I can plug in 7 for t and 1,200 for y and use that to isolate k, to figure out what k is. So 1,200 equals 1,000 e to the k times 7. Well, let's divide by 1,000. So 12 over 10 is 6/5. So 6/5 equals e to the 7k. Now let's take the ln of both sides. Those will cancel out. And so I'm going to get the ln of 6/5 equals 7k. Divide by 7. And we'll get the ln of 6/5 over 7 equals k. So I'm going to go ahead and write this. This is probably a calculator question, but I'm just going to write it as if it wasn't. Y equals 1,000 e to the ln of 6 over 5 over 7 times the time. So again, this is definitely a calculator question, but let's just kind of pretend it wasn't. So then how many people are infected 12 days later? Well, that would be y equals 1,000 e to the ln of 6 over 5 over 7 times 12. And that would be the answer I would look for. They could as well, maybe put 1,000 e to the move the 12 over 7 in front and kind of put this as ln of 6 minus ln of 5. They could do that, right? Because when you divide, that turns into subtraction. So that could work as well if it was, multiple choice and they gave you those as answers. But in this case, they gave us numbers. So what we're going to need to do is just take out our calculator. This would have been a calculator question. Your exam will not be calculators. So you won't have something, you'll have maybe something like this, but the numbers will work out nicer, or, these will be the answers, right? That's kind of why I highlighted these, is this would be the answer, choice A, B, C, or D, right? Or you'll have something like the other one we had, I think it was question 18. Yeah, where, we just see how they kind of ended up with LNs. right? So that's kind of what might happen for us. So anyways, what we would do is get our calculator, type that in. Mine is loading, so give me 1 second while mine loads up. Yeah, my calculator, I have the calculator on my computer, but it's just super, super slow to load. I don't know why the app is just like so lame. It's a really nice app once it loads, but it takes a long time to load. And then the other thing that's really dumb about it is it won't close. Once it's opened on my computer, there's no way to close this. It's like super, super frustrating. Like I can hit the X, and like when I hit the X, just nothing happens. It just stays there. So it's kind of lame. So anyways, so we got our calculator. Oops. Okay, there we go. So I'm going to add a calculator, and then we wanted to have 1000 e to the ln of 6 over 5 over 7 times 12. So if I just type this in like this, make sure you do times 12. It's probably going to just give me the answer back or something weird like that. So I'd want to hit Control Enter to get the decimal. And we get 1366.9. So 1367, something close to 1367. So that would be choice C. So that's it for the practice test. I did promise you guys that we'll kind of look at another, kind of old AP exam question. So give me 1 second while I pull that up. There we go. So here's kind of just a bonus question for us would be, this is from the 1998 exam. So from our 1998 exam, if I can get it. Okay, so this is another one where like Sam was asking about how to do some of these. And so on this one, let me see, yeah, there we go, we got it writing. So kind of same thing, let's plug in 1 and 1. So x is 1, y is 1, and I want to have a positive slope. So 1 plus 1 is positive, this worked. 1 squared is positive, that worked. 1 plus 1 is positive, that worked. 1 over 1 is positive, that worked. And the ln of 1, this one doesn't work. The ln of 1 is actually 0. So we can cross out choice E. We know it's not E. Okay. So now I'm in a different app, so I'm not sure where the colors are. So I think I'm going to just have to keep the same colors, which is kind of unfortunate. But now let's plug in. And this is actually something where if you kind of look on this one, we can see kind of these zeros. So we could even use these zeros to our advantage. It looks like I'm getting a 0 at 1 and -1. I'm also getting a 0 at -1 and +1. I'm kind of getting a 0 whenever they're opposites. So if I notice that I'm getting a 0 whenever they're opposites, it's probably choice C. It's probably like a super easy one to just pick out. And so I'm going to kind of go with that. But we could confirm it. So if we plugged in 1 and -1, x is +1, y is -1, I'm supposed to get 0. Well, 1 plus 1 doesn't give me 0. 1 squared doesn't give me 0. And 1 divided by -1 doesn't give me 0, so it's choice C. You could have tried to plug in other values, but really that's an easy pattern that we kind of see across. And so we kind of picked that out. So that's something where Sam had asked, what points do you recommend earlier? And if you see a pattern like that with all those zeros, I would recommend trying to figure that out because that can really eliminate things quickly. Now, if you hadn't done that, yeah, we could have gone in and plugged in some of these other points. So like in quadrant 3, x is negative and y is negative. I'm supposed to get a negative answer, right? And 1 minus 1 gives me 0. So I could cross out A again. Negative 1 squared gives me a positive answer. So I could cross out B again. And negative 1 over negative 1 gives me a positive answer. So I could cross out D again. So if I hadn't done that, I still could have done that thing earlier where I look at each quadrant, right? And then here, negative 1 minus negative 1 gives me negative 2, and it was supposed to be negative down there. So I still could have gotten into my right answer a different way. But if you see something like that where, hey, all of these across are all 0, then that's what you want to pick out. Okay? Now, one more thing. I don't have an example for this for you guys, but they could have also done a slope field question like this where instead of asking you for the differential equations, they ask you for like y equals graphs. And if they ask you for that, just go ahead and graph it, kind of try to graph it. So, look at what this graph might look like. And this graph looks like it's decreasing, comes to 0, and then is increasing. Right, so it's something with an even exponent. It doesn't quite look like a straight parabola, right? Because this looks like it's steeper on this side and less steep on that side. So my guess it would be something, with an even exponent. And so you just kind of pick out, hey, what graphs do I know that look like that? We didn't have any of those on the practice test, so they're probably not going to be on your real test unless it's a bonus, but just kind of pointing that out as well. Okay. Thank you for those of you guys who are here, and thank you, Sam and Anthony, for participating in the chat. I appreciate that. I may throw some extra credit your way. And if you're studying later, then that's fine as well. It's study the best way for you. So if you're watching this later, that's awesome. Email me if you have any questions, and then we'll do the same thing with the free response tomorrow. So we'll do the free response section tomorrow. Okay. Have a good day, guys, and I will see you later.